some next example we're going to take you through. So in this case, we have diaphragm reaction to bracing connection. So typical CLT floor to GLT beam connection. So in our case, this is going to be at the position of vertical bracing. So as a part of lateral resisting system, how force is transferred from diaphragm to vertical bracing. And in that case, we already have a reaction force that we have from diaphragm. So in this case, we use these numbers for calculating our example. I'm going to just briefly show you once again what are the possibilities with specific connection details. So we have exact connection detail where you can have this design in particular for CLT to GLT connections, but bigger flexibility and power is now available in screw design. So I'm going to use this maybe at the beginning harder part, but just want to point out what are the new features and possibilities with our screws. So I'm going to open another tab where I already opened the screw design or module. So this is something that we recently released and that is available for everyone in Europe. So in this case, for the screw design, you have ability for selecting different materials for each member. So you can choose for first member between softwood, LVL, hardwood, beech, LVL, plywood, CLT, GLT, or steel plate. Same for the second member, with the exception that steel member can only be selected for the first member. In terms of the another more configuration options, so we have here connection type. So as I showed you in the previous example, we can choose between discrete and continuous, or are we calculating specific connection detail, or we're we'll have a line connection or have this design by meter per meter. And also we have here a grain orientation, so we can always switch between end and side grain. In terms of the dynamic imagery, we have the same or similar preview of what's happening in the design. So we have option to see what's happening in our connection, with option of showing the value and label. So we have overview and control what's happening. But the biggest improvement we have in this screw module is on 3D design. So you can easily change to 3D and see what is happening from all the angles, and also you have a power to see what is some of the things to configure what is with inside view, dimensions and values, or to see practically all information in one place. If we go further, we have option for loading data, and what is the biggest improvement here is that user have flexibility for inputting loads in all directions. So you're not limited to only lateral loads, but you can combine axial and lateral in both directions. In this case of our example, I only used the lateral load in one direction, but just wanted to point out how powerful this connection module is. In terms of the design methodology, so again, Eurocode 5 is selected, but for all connections and or screws currently, you have ability for even selecting the new Eurocode. So that's something that I can show you on the end of this design example, and how effective can be in some connection design examples. In terms of the perimeters, so again, we have some specific coefficients that we can use. And for the member design, in this case, I wanted to show flexibility around suppliers. So in this case, I've pre-selected X lambda limiti, and I pick up the same 5 layers, 180 millimeters layup. For GLT, we currently have option for manually configuring all the dimensions, but and you can also input what is the density characteristic in main, so that's needed for connection calculation. But that's also something that will be improved in the short time, and you also have ability for selecting grades, so you don't have to worry about that option of manual input. The biggest flexibility and improvement around fastener data here is regarding to not only selecting the screw suppliers, but also in terms of the filtering system. So for first part is on regarding to the member type. So this is based on the inputs from the beginning. So if user selects timber to timber, it will be automatically set to timber, or steel to timber. It will just show you what screw filtering is applied here. The second type of filtering is regarding the thread type. So here we only can see the screw that's being filtered by either partially threaded or fully threaded screws. So actually the screw families in this case. So for this example, I selected Klimas and WKCP screws. And also the very good improvement that we recently released is on the smart lanes. So depending on the configuration you select, you can when this is turned on, you can see only screws that are applicable for or compatible with your dimension or member sizes. If this is turned off, you have ability for selecting either also screws that are with less length and diameters that won't practically be appropriate for this connection. But we provide this flexibility, so both options are available here. Design methods again can be chosen between the Eurocode or ETA from the supplier. And also what is great about this module is the ability of configuring geometry. So there is ability for manual input where you have all the flexibility and you can practically play with this easily and then see what is happening with the minimum distances and position everything properly. But in terms of the standard arrangement, this is very useful, so you don't have to worry if your edge or intermediate distances are satisfied. This is something that will be automatically set by the software. What is up to user is just to select the number of screws, which is limited with a minimum or and or intermediate distances, and also that's something that is along and parallel to the grain as well. In this case, I pre-selected the 6 screws per meter, but if we go lower, that will be automatically changed. So you can see that that's not possible, or if we have too many screws, you can see that the utilization is not optimized. So this is something that user can play and see what is the best possible design for their scenarios. In terms of the results, we have here option for screw verification. So all the information are listed here. We have separate tab the tab for rope effect calculations, and all the references and information regarding this is visible next to part of verification. So we try to point out where more information and where these verification are from. The same approach is for the shear capacity. So here we have all the failure modes together with dynamic imageries. So we work a lot to improve user experience in designing connections. And the last part is on the design capacity. So we have here all failure modes, effective numbers of screws, and lateral capacity of connection. What I wanted to point out is also that you can, through all the inputs and from the beginning to the end, you can use the more information part. So that's these green dots next to the input. So whenever you select this, you'll see additional inputs and information in terms of either inputs, either selections. So in this case, when you select some of the screws that you might not familiar with that, you can easily go through all of their practically products, and in green is product that is pre-selected, but you can always have information about the screw type, thread type, head type, diameter, length, service classes, and some of the specification. As I mentioned in the beginning, I can show you now what and how new Eurocode can be beneficial in some of these design process. So even it's not fully adopted and official, you can still use this to practically compare the results. But what is more interesting, when you select the new Eurocode, you don't just verify the shear capacity and the geometry text, but you can also see what's happening with brittle failure modes. So in terms of the connection with more than one screw, that's something that can be governing in the connection design. So it's important to see what's happening with raw shear and net tensile resistance. And in that case, we have a specific tab where you can run through all the connection specifics and see what's happening with brittle failure modes.